Hello, everyone, and welcome to kata decomposition. So, this is kind of like an applied problem solving thing. So, we're going to take some of the skills that we've been learning with Polya's problem solving method, etc., and see what this looks like on sort of a weird, gnarly problem. So, we're going to be looking at the Gilded Rose kata and trying to figure out how we can take this like very complicated problem and hopefully make it into a bunch of simpler problems. Okay, so let's take a look at the Gilded Rose. All right, so one of the first things that you do when you look at a problem like this is we got to figure out, what do we have, what are they asking us to do, and what are the constraints. So why isn't the unknown just one of the things that they gave us? So I'm looking at John's. Say this is a finished one. Why is John Lake on here? Let me pull up the original. Maybe it was forked. There we go. All right, there we go. So, welcome to Team Gilded Rose. You are asked to help build our store inventory management system. All items have a sell-in value, which denotes the value of days that we have left to sell the item. Okay, so like as I'm reading this, one of the things that I'm pulling out as a given are, we have items. I don't know anything else about that yet. I just know that there are items. So given some items, items have a sell-in value. Notes the number of days left. So that's number of days left. And a quality value, which is how valuable it is. At the end of each day, our software should lower both values for every item by 1. So for right now, I'm going to put that in the constraints column. Items go down in quality by 1 each day. All right. So, and then also both values for every item. So items go down and sell in by 1 each day. Okay, and then we have some exceptions. Sell-in days are less than 0. Quality degrades twice as fast. That's another constraint. So that's if sell-in is less than 0. Quality. So like this is where we start doing some interpreting. Quality degrades twice as fast, so that means it's going to, it normally goes down by 1, so now it goes down by 2. The quality of an item can never be negative or increase beyond 50. So quality maxes to 50. Quality mins to 0. Aged brie goods actually increase in quality each passing day. So that's going to be a difference in this constraint. So items go down in quality by 1 each day unless aged brie goes up by 1. It's still constrained by not being able to be more than 50. Sulfurous goods never change their sell-in or quality values. And so that's another change to that constraint. So unless sulfurous doesn't change. That's also the case with this. Unless sulfurous doesn't change. Cool. Backstage passes, like aged brie, increase in quality as its sell value decreases. Oh, I see. Backstage passes are another one. Just like aged brie goes up over time, backstage passes go up as well. Aged brie is an example of a backstage pass. So these increase in quality as sell-in value decreases. So that's another change to this. Unless backstage pass goes up by 1. Backstage passes in quality increases by 2 when there are 10 days or less. Ooh, interesting. So that's goes up by 1. Oops. 2 when there are 10 days or less, but then it's 3 when there are 5 days or less. So we can translate that a little bit too. So goes up by 1 if sell-in is greater than 10. Goes up by 2 if it's greater than 5. It's 5 days or less, yeah. 3 if it's 0. If it's greater than 0, and then otherwise 0 if it's 0, because we can't go any lower than 0. Complicated enough? Yes? Now there's a new category that we would like to see added to the inventory management system. Conjured items degrade in quality twice as fast as normal items. And so that's another change to this constraint. That would be unless conjured goes down by 2. Okay, extra clarification. An item can never have its quality increase above 50. Got it. Sulfurous is a legendary item. Always, so its quality is always 80 and never changes. So we have that. Doesn't change. So we also got is 80 out of that. Another constraint, no mixed categories. Category might not be first. Okay, and then they give us some sample items. All right, so they have a name, a sell-in, and a quality. So we also have a name. Write a web app that allows you to add new items and displays the current state of the inventory. Degradation should be calculated based on the date the item was added. Note you'll need to parse the name of the item to determine its type. And then all this sort of stuff. So the unknown is how do you write code that stores items, adds items, and then with all, what the purpose of all these constraints is current state of the inventory. So calculates sell-in and quality based on date. Cool. That's Polya step 1, part of Polya step 1 for Gilded Rose. And that's that's not for show. That's exactly how I do problems like that in interviews, like anything like that. Read through it, figure out what stuff matters, what stuff doesn't matter. Like this whole like Gilded Rose shit, it's distractor text. That stuff doesn't matter. This is the stuff that actually matters in the problem. And so when you look at all the things that matter at the same time and you group them based on how they need to be, that's how we start getting to a problem that we can solve, or at least tear apart. So it's like we can make smaller problems with this too. So an example might be items go down in quality by 1 each day unless these 4 things. So then like a smaller problem could be something like given a name, or I guess a category would be even more useful. Given a category, then how does quality change each day. Some of these are relative to the selin, so we also need the selin and the quality. So given those three things, how does the quality change each day? And our constraints, it's going to be a little bit like what we did here, but the problem is actually a little bit easier. So conjured minus 2. Backstage pass, let's see, plus 1 if greater than 10, and plus 2 if greater than 5, and plus 3 if greater than 0. All of this is selin, and 0 if 0. And then sulfurous is always 80, and aged brie goes up by 1. So like this is a subset of the problem. No adding items, no, we don't even need to manage like the actual logic of changing dates or anything like that. All we need to do is, if I am given these three things, can I figure out what the quality should be doing? And that could literally be a function. That can be like, get change that takes in a category, a selin, and a quality, and returns plus 1 or negative 2 or 3 or 80, something like that. And like this, that's just like an if-else statement or a switch. So like that logic is pretty straightforward. And if we think that, okay, if I had this function that could just give me what it should be each day, the rest of this problem is substantially easier. Like this is half of the hard shit right there. It's really like almost all of the difficulty of that is in this much smaller, much more straightforward math problem with like some very simple conditional logic in it. Anyway, that is the approach of how one goes about decomposing a big problem. Ask me some questions about it.
When we're talking about constraints, is it by and large going to be, hey, these are the conditions for your solution, and they can usually be broken down into these smaller problems?
Yes. Your givens and unknowns are usually pretty unambiguous and straightforward. Sometimes you have to like interpret them or dig them out or something like that, but they're usually not complicated or confusing. The constraints is where the complexity is in the problem. Ask me more questions.
Kind of going about this in my head and how I would go through working this. And the only thing I can think of is the only thing I'm not sure of is how I would measure the passing of each day. So I'm thinking I'll probably just go find I bet there's maybe a module or something for that. Maybe.
So, pro tip, I wouldn't worry too much about trying to fake out dates. So what you can do is like, so when you're putting this stuff in your fake database, like put dates in there that are uh, added yesterday, added 3 weeks ago. Like put those things in there, and then just compare them to today. And then to test your code, just change like what date those things were added. So this will show up as like an array of objects. Have another property with the date that they were added, and then calculate it based off of that.
Okay, that'll be easier for
Yeah.
sure.
Also, like I'm totally cool with not doing any date math. So like you can just do pure numbers for this. So that could be something like sell in 10. Well, it was added -8 or something. It's like something like that, rather than using actual dates. So you could say like today is 0 and this was added 6 ago, or -6, or something like that. That's totally fair too.
Cool.
So we don't necessarily need like a button that adds one day and then everything else
No.
changes?
Nope.
Okay.
All I care about for this assignment is the logic of this. It doesn't need to actually track the passage of time or anything.
On the quality of each item,
Uh-huh.
they're just based on the date itself rather than, they don't have a starting quality, correct?
They do. So, like, these are all examples of starting quality.
Okay.
And that could be part of the form. Like, so when I started mine, part of my form input is the starting quality. Can we
Yep.
do it that way?
Correct.
Okay.
Yeah, everything should have a starting quality. That's something you could infer out of that.
Would we also be able to make these as like a list of objects, and each object has, for example, the starting quality as a property?
Totally.
Okay, perfect. Instead of plugging it in on a form? Okay.
Another smaller problem in here is when we're calculating this, we need the category. Well, these don't have a category. We're not given that. We need to calculate it. And part of what they did is that the stuff isn't always in the first position. So, like, I don't know what all those are. Let's see. So yeah, you're looking for particular values like conjured. So then you would also have the problem with how do I get the category out of a string? And so you go, okay, well, what are like the things that I could be looking for? Well, conjured is one of them. Sulfurous is one of them. Backstage pass is one of them. And so you could write a function that tests a string for one of those values. And one of our constraints was we know that the category, or that there's no mixed categories. So if it finds one of those, we don't need to keep looking. We just need to find if it has a match for any of those. And if it doesn't, then we know that none of these like weird cases apply. And like
I have another question. Oh,
I was gonna say that that's super representative of real programming too. You get something like this that you're trying to do, and you go, huh, wow, that's an awful lot of things. What smaller problems can I find in here? How can I calculate how the quality changes over time? How can I figure out what the category is from a string? And all of those are small problems. And when we add together all of our small problems, we get the big solution. Parnell, what was that?
oh, I was gonna say, so for the category, I just added it as one of the inputs of my form. So, it
Don't
just
do that.
goes around.
Don't do that.
No.
Now, what you can do is like, you don't have, like if you do these as an array of objects, you don't have to only use this. You could add a quality thing, but part of the problem is figuring out how to get that category out of the item string. It's part of the problem.
Okay.
But yeah, another way to phrase that problem, the simpler version of it, is can you find a substring inside of a string? Well, shit, there's a built-in JavaScript function for that. So um, that's the kind of thing that we're talking about. More questions about kata decomposition? To recap, when you're reading through these problems, figure out what your inputs are. Like all systems take inputs, generate outputs. What are the inputs? That's your givens. The unknown, that's our outputs. The constraints are all of the like wheels and gears that this stuff has to go through inside the box. The constraints are where the hard stuff is. Inputs, outputs, hard stuff. Try rewriting the problem. Pick out the relevant pieces. Get rid of the stuff that doesn't matter. See if you can find smaller problems inside of it. Damn, it almost sounds easy. And like, it never is. But one of the things that tends to happen when you're working through this stuff is it's pretty common to have some false starts where you crank through it for half an hour and you go, I completely misunderstood this problem. And what your temptation is going to be is to just keep cranking ahead anyway. Fuck it, start over again. Just wipe the slate clean. That is usually a faster way forward when you're doing those things, because the hard thing isn't like actually implementing a solution to something. It's figuring out what the solution is in the first place. Think about it this way. If I gave you a solution to the Gilded Rose problem and all you had to do is transcribe it, that wouldn't take very long, right? That's like a 5-minute long thing. That's I go, all right, make your screen look like my screen, and then I go get a drink of water and come back. So like, once you understand what the solution is supposed to be, it doesn't take very long to do it. It's figuring out what the solution is that takes a long time. And sometimes, like, I worked myself into a corner. I sort of framed this whole thing wrong. Scrap it, start over again. But you're not actually starting over again. You're starting with whatever you like learned from this last round. And so if that takes 3 or 4 rounds through solving a problem, that's not even that weird. Each cycle through, you're bringing more experience and knowledge to it, and that's valuable. All right.
Will you be posting this video a little bit later?
Yes, I am.
Because I haven't gotten to reading the store inventory assignment yet, so I'm
All
a little
right.
lost, but I'm hoping once I read it and then I can review your video, then I'll understand a little bit more.
All right. Well, we like that's 100% of it. We read through it together. But yes, the video will be posted.
Thank you.
Cool. Anything else we should talk about for the next lesson? All right, that's a winner.